Density is one of those properties we're familiar with. Grams per cubic centimeter or grams per milliliter. But it is also one of those properties that does not depend on how much material you have. This is sometimes called an intensive property. A small amount would have a small mass and a small volume. A large amount would have a large mass and a large volume. We should be able to measure density regardless of the size of the sample. And we should be able to get density on a sample as small as a unit cell. If we want to measure density, we need to know the mass of our sample and the volume of our sample. In other words, how much mass and volume are inside the unit cell. For any element, we can compute the average mass of one atom. For the 3 cubic unit cells, we have talked about how many atoms are inside a cell. That's the unit cell stoichiometry. So, knowing the mass of one atom and how many atoms are present, we could find the mass of a unit cell. For the volume, we need to know the length of the side of the unit cell. Remember, the cell is defined by the nuclei of the atoms at the corners. So the distance between the nuclei at the corners gives the length of a side of a cell. It is given the symbol A. Of course, being a cube, it can be measured going across, up and down, or front and back. The volume of the cube would then be A cubed. If we know the identity of the element in which cubic unit cell the element crystallizes and the length of the side, we could actually calculate a density. But even without a calculator, we can make some comparisons. For example, silver and gold both adopt the face-centered cubic unit cell. For each, the value of A is 4.1 angstroms, which is 4.1 times 10 to the minus 10th meters. Which is more dense? Let's think about the density expressions for each. Since the A value is the same for each, the volume of the unit cells are the same as well. For the mass, we need to consult the periodic table. The average silver atom weighs 108 AMUs, while an average gold atom weighs 197 AMU. Since each element crystallizes in the face-centered cubic arrangement, the mass inside the silver cell is 108 times 4. Recall that there are 4 atoms inside a face-centered cubic cell. The mass inside the gold cell is 197 times 4. If the volumes are the same and there's more mass in the gold cell, gold will have a greater density. Of course, if we actually wanted to calculate the densities, we would need to find the volumes in cubic centimeters. And we would need the mass in grams. The mass in grams would be the molar mass divided by Avogadro's number. But notice we didn't need to do those calculations and get the actual densities to answer the question. Here's one more. Solid argon adopts the face-centered cubic cell, while solid potassium adopts the body-centered cubic cell. For each cell, the value of A equals 5.2 angstroms. Which is more dense? Again, since the value of A is the same for these two, the volumes are the same. When we look on the periodic table, the masses of these two elements are almost identical. Argon is 40 and potassium is 39. But argon is face-centered, and there are 4 argon atoms inside the cell. So there is 40 times 4 AMU inside the volume of the cell. Potassium is body-centered, so there are only 2 potassium atoms inside the cell. Since there is twice as much mass inside the argon cell, argon will be more dense.